And we're recording. Love it. Comments, questions, concerns on any of these things. If you made a mistake, you understand why. Again, I wanted to know calculator. I want you guys to develop mental math techniques. There are many. I find it, being a math teacher, my friends all know that I'm a math teacher. My family obviously knows that I'm a math teacher. And it's really interesting the number of times where I'll have a conversation with like my adult friends, or sometimes even my wife, and she's like, she says it really funny sometimes. She's like, so I just learned this technique for like, because she's dealing with like money and amounts and stuff, large numbers in her. Like, so there's this really quick, mental math trick that I learned. And I'm like, yes, that is a thing. This is the kind of thing that I teach my grade 9. She's like, I wish I would have learned this in grade 9, middle school, or wherever. So if you have these mental math techniques, don't take them for granted. I have adult friends who are mad that they don't know what you may or may not know. So, again, this was supposed to be mental because I'm not going to let you use a calculator on a test or a quiz. So if you use a calculator for any of this, please don't. Was this relatively easy? We were able to do this fairly quickly? Fantastic. If this was not relative, sorry, Nika, is that a hand?
I'm not sure if I was the only one who was confused, but for the calculator at the top, the division stuff, I thought it was 10.72 divided by 9. Yeah, I did that too. Yeah, I didn't realize that was question number 10.
Oh, you are not the first person to make that mistake. It's not even a mistake. To see that as being, so that would suck. If that would be an awful question to give you. I don't know what 10.72 divided by 9 would be, and I would never expect you to do that without a calculator. Unless, you could go back long division. You guys learn long division still in middle school? Like, you don't remember, like, none of you learned this? 10.72, and then, like, the 9 goes into the 10 once, and you 1 times 9, and then you subtract and bring down the 7. And then that's going to be 1. 1 times 9 is 9. And then you just subtract, and that's 8. And then there's a 2. We don't remember this? Yeah. We're just going to... Yeah, I'm sorry, Nika, for your confusion. Should that ever arise in the future? Like, did you just not notice it? Or you, like, what was your thought process when you came to that question? You were like, what?
I don't know. I was trying to do it with a long division, and I realized it eventually, but I already done all the questions.
I'm really sorry. That's the kind of thing where if you notice something's weird and you have a feeling within your heart that something's not right, you can always email me. My Learn34 account goes straight to my phone, and you can ask previous classes. I'm pretty good at getting back to you guys fairly quickly. So, that's a thing. Cool. Then if we're good, love it. Hoping this is something you guys are fairly comfortable with, multiplying and dividing integers. One thing I want you to recognize here, jumping now. So do I need to see anything more about multiplication? We're cool with multiplication? Bless you. We know our times tables? More or less, sort of, kind of? I didn't what? Okay. Oh, there was one thing we didn't actually finish putting in holes here. If there's in chains of multiplication. So if I've got a bunch of things multiplied together, if there's an even number of negatives, your answer is going to be what? It's going to be positive. Because every 2 negatives is going to cancel out and leave me with a positive result. So that odd number of negatives, you can pair them all together. It's pair. With the odd number, there's always going to be 1 negative left over, which means your final answer is always going to be negative. Cool, thank you. And we didn't go through this because I kind of figured you were good with this. One of the things I want you to remember is, and again, this came up not that long ago with an adult friend of mine. If you look at how we write division, 20 divided by 4, that division symbol looks an awful lot like what? A fraction. Has this been pointed out to you before? Okay, I have adult friends who are like, again, they know I'm a math teacher, so they tell me random crap like this. They're like, did you know the division sign is just a fraction with dots where the numbers are supposed to go? Like, yes. Yes, I did know that. But thank you for pointing that out, and I'm so glad that you now at 34 also know this. This division, if you didn't, I mean, I don't have the same expectation for you guys. If this was never pointed out to you by a middle school teacher, this was never pointed out to me. I just kind of was like, oh yeah, that makes sense. But at no point in my educational career did a teacher actually go, this is the relationship between division and fractions. They're the same thing. And the symbol for division is just a fraction with with a dot in the numerator and a dot in the denominator for this value and this value to occupy. So 20 divided by 4 becomes 20 in the numerator, 4 in the denominator, and it can be written like this, 20 divided by 4 equals 5. I have taught pre-diploma now for 6 years, and I have students who have made it through pre-diploma who still don't understand that there's a connection between writing things as a fraction and writing a division statement, because a fraction is just a division statement. That's all it is. And I will bust on my grade 12s for that forever. I will not bust on you guys for that, because I don't know where you're coming from, but now having come through my class, I will mock you relentlessly for it in future years, should you forget that fact. Not relentlessly, I'm not that kind of person, but it'll come up. We're cool with that idea? This is a fraction. With the dots instead of numbers in the numerator or the denominator. If that's brand new, if that's revelatory to you, that's fine. I'm not going to bust on you for that. It's my 34-year-old buddies who are like, oh, this is earth-shattering. I'm like, it's not earth-shattering. But I'm glad that you finally learned it. That's awesome. Okay? So this symbol right here, that's just a fraction. And when we deal with fractions, it's just division. Except what we typically don't like about fractions is that they often don't nicely divide. And so what we're left with is effectively a remainder. That's where these partial fractions come from, is the remainder upon division. Remember what remainders are? Yes? Something that the divisor can't actually go into fully, right? So if I had something like, I'll write it out here. If I had like 21 divided by 4, if I wrote it out like this, if we're going long division, 4 goes into 21 how many times? 5 times 4 is 20, and I bring down the 1. If I'm not going to put a bunch of decimals here, if this is where I'm going to leave it, I would say that my answer is 5, remainder 1. How many of you were taught to do this at some point in elementary school? Okay, cool. When we deal with fractions, I could say, okay, well, what's 21 fourths? We're going to talk about reducing this today, because you all should know how to, or at some point in the past should have learned how to reduce fractions. Sorry? You kind of sort of tried to square root both of them, sort of, and things got weird. How do I reduce this fraction? I'll give you a hint. It's very similar to what we did over here. Here we said, how many times is 4 going to 20? 1. Here you do the same thing. How many times is 4 going to 21? 5. How much do I have left over? Because 4 times 5 is 20, I've got 1 left over. That stays in the numerator, and my denominator stays 4. These two statements are exactly the same. 21 divided by 4 is 5 remainder 1. 21 divided by 4 is 5 and 1/4. Those statements are equivalent. And I don't know obviously I've never taught middle school, I've never taught elementary school. I don't know how these things get taught at that age, but for some reason I have witnessed in lots of students, not everyone, but lots of students, they're cool with this, but the idea that this is a thing and is just a division statement makes people really uncomfortable, and I'm not sure why. If you are one of these people, that's not a judgment call. I'm not saying that's good or bad. But if you want to enlighten me a little bit here, that would be cool. Is there anyone out there who this as a division statement makes you uncomfortable? And you're willing, and you want to share that?
It's just unfamiliar.
It's just unfamiliar.
Yeah, I'm not uncomfortable with it. It's just a bit weird to you always do the long division instead of, oh, do it this way.
Oh, so you're just not as familiar with it.
Yeah.
Okay.
That's it.
And when you were taught fractions, you weren't necessarily taught that. Here you're just taught to reduce fractions when it is just division.
Like we'd be taught to do like how many times 4 goes into 21. That's 5. But then I would have thought that it would be like you. I would have thought that it would look different and not be 5 and 1/4, even though that makes sense. Like now that you did it, I don't know. I would have done it differently.
Okay. Want to do the long division again? Sorry, that's a 4 and a 5. 4 into 21. Except instead of writing the remainder here, I'm actually going to keep going. 5 times 4 is 20. I'm going to drop the 1. Now, what do we do here? If I don't want a remainder, if I want an exact value, what do I do? Who remembers long division? I throw a decimal down here. Yeah, 4 doesn't go into 1, so I need to start adding some things. I throw a decimal down at the end of the number, and I add a 0. So now I'm bringing down the 0, and I'm going to say, okay, how many times does 4 go into 10? 2 times. 2 times 4 is 8. 10 times, or sorry, 10 times 8. 10 minus 8 is? Does 4 go into 2? No, so I'm going to add another 0, bring it down. Does 4 go into 20? You bet. It goes in 5 times. 5 times 4 is 20. It's going to leave me with no remainder. So now I've got 5. And this, where the decimal was here, it goes straight above it. So now I've got 21 divided by 4 is 5.25. Well, that's the same as the reduced fraction that I had before. So the division is, these two are more obviously the same. The question is, well, what happens here? This doesn't necessarily look as nice, because back in the day when you were taught how to deal with remainders, people probably didn't tell you, well, this isn't actually the correct way to write the answer. How we actually want to write the answer is 21 divided by 4 is 5 plus whatever my remainder is divided by 4. Well, that's just this, which is just this. And so sorry?
Isn't 25 divided by the percentage of 1 over 4?
This decimal here. So what does it mean for it? Oh, we're going to talk about percentages, but what does it mean for it to be a percentage? What does percent mean? I'll give you a hint. Percent. Sorry, who said that? Where does it come from? How do you know?
Percent is 100.
In what language? Pretty sure it's French. En français. Percent is per 100. Thank you for knowing that. That's where the idea of a percent comes from. And then the English were like, we need a word, but the French have it. You know what? We'll just bastardize it like we do with so many other languages. And they yank it out of French. And they said percent, that's English now, means for every 100. And that's where we get this. Because we have 25 100ths, that would, we could write this 5. Well, this would be 525%, because you've got 5 wholes and 25%. Yeah.
So is it just this question, like, you could take 1 and divide by 4 and you get 0.25?
Yeah.
Right? So would you have to do all the steps? Like, would that be the same for every single question? You can just divide the remainder by what's that called? The number you're dividing.
The divisor.
The divisor, like by 4. Could you do that if it was like?
You can always, this is mathematically true, doesn't matter what the numbers are.
Okay.
Sometimes it doesn't work as nicely, like the division won't, like it won't give you a nice decimal. But everything I have done here is mathematically true regardless of the numbers you put in.
Even if you took, like, without dropping the decimals and doing all that, even if you just did 1 divided by
Like right here?
4.
Yep.
That would work?
Yep.
With any numbers?
Yep.
Oh, okay. That'd be a faster way to do it.
Well, that's why, I mean,
If you had a calculator, though. Or if you know that you're, like, it's obvious that a quarter of 1 is 0.25. 25 plus 100.
yeah. The fractions will get grosser. Like if this was a 7th,
Yeah.
I don't know my 7th fractions. I don't expect you guys to know your 7th fractions. There's always a couple kids who know their 7th fractions because they had that one kind of masochistic middle school teacher who was like, okay, kids, we're going to learn our 7ths today. And that's just mean. But yeah, if the fraction is nice, it can be a quick way to do it. To recognize that these are all equivalent expressions is important. That doesn't necessarily mean you now all accept it easily and are like, yes, this is now just going to become a part of my being and it's easy. I think, Danny, you put it a really good way. You're just not comfortable with it, and I think that's a good way to recognize it. But if we can get you guys comfortable with it, I think that's my goal here. So, we can do all of these. Yes, I don't need to spend any time doing these. Let's just do it real fast. What's this first one? -8. Thank you. This one is 9. Love it. This one is. We sure? We're not sure. It is in fact 10. And this guy is? No, it's not 125. It's -125. Those are different numbers. It's like me versus my evil doppelganger. Those are different people. Come on. Has everybody seen Community? We've not watched Community? Okay, never mind. Forget I said anything. Evil Mr. Dweedoff from the darkest timeline. Okay, bed mass. Something totally new. Well, not new, but different than the stuff that came before. What's bed mass? Hands up. Yes. It is the order of operations. We like this. This is the law for mathematics. You must do things in a particular order, because if you don't, now you're just making crap up and it's not going to work. So what does bed mass stand for? And is it always just bed mass, or are there other abbreviations we could use here? Ooh, hands up if you've heard of PEMDAS. Someone else said something else. What did I just hear? Okay, so who said that it's just parentheses? Let me show you the difference between brackets and parentheses. Is there a difference? Yes. See, this is because you've never had a real math teacher up to this point in your life. Welcome to my math class. Okay, so bed mass, we'll start with bed mass. What's it stand for? Brackets. Then exponents. Then I'm a math teacher, but I can't spell. Multiplication. A is addition. And then subtraction. I'm just messing with you. It's subtraction. Okay. So, some of you said, well, this is just PEDMAS or PEMDAS is the same thing as BEDMAS, just P instead of the B. It's just brackets, parentheses instead of brackets. Those are different mathematical objects. We use them interchangeably, but they are different. Does anyone know the difference? This is a bracket. This is a parenthesis. I'm going to spell it here. Parentheses. And they call it parentheses plural because they always come in a pair. Parentheses look like this. These are brackets. These are parentheses. So these are parentheses, yes. So we've been using parentheses ever since, but they just told us it was bad. Yes. And I'm going to use those words interchangeably because it ultimately doesn't matter. But yes, it's important to recognize that these are in fact different things. And there are different kinds of brackets. You can have what are called angle brackets. Let's say you don't want to make squares. You're like, you know what? I'm liking rectangles today. Those are angle brackets. They exist too. Those are different. They operate the same way, But because they are different objects, they get different names, even though they do things very, very similarly. Should any of you choose to go off and want to study physics, you will take a course one day called quantum mechanics, and they actually turn brackets into mathematical operators that do something other than just hold things. They look like this. That is a bra. This is a ket. And things go in the middle here. And whatever is in the middle gets operated on by the bra and the ket. Depending on the kind of bra and the kind of ket, the different mathematical operations. Every time I say the word bra, y'all gonna giggle? Yeah. Fair enough. I did too the first time. So this thing here is a bra. This thing here is a ket. And these things are mathematical operators that you're going to learn about if you ever decide to take quantum mechanics, which I'll just abbreviate as QM. Fun fact. Okay, now back to the order of operations. We're going to forget about bras and kets. We've got bed mass, ped mass, and PEMDAS. We've already established that the P and the B are interchangeable. One's parentheses, one's brackets. But there's some other kind of weird ordering going on here too. How are they different? How are PEMDAS and bed mass, the multiplication and division are in the opposite order, but both of these are acceptable orders of operation. How? When you say whichever one comes first, what does that mean? How are you reading it? Yes, if you say it, you have a tone. You have a tone like that shouldn't need to be said, but it absolutely needs to be said. Thank you for saying it. This must be done left to right. Okay, carry on with your explanation. Why can we do that? There's an important mathematical reason why that's true. Yep. That's all I ask for. Yes. Nika, give yourself more credit. They are opposite operations, and we have a word for that you may have heard in math class. Starts with an I. I-N. Almost not quite. I-N-V. Who said that? Nika, say it again. Almost. They are inverses of each other. They are inverse operations. It means they're opposite operations. The reason that we're allowed to do this is because division and multiplication are inverse operations. I'm going to put a slash here, inverse or opposite. Yes? Oh, the E is exponents. P and E, that order will never change. PE and then BE, those orders never change. But when you've got the multiplication division or the division and the multiplication, you can do that because they're inverse or opposite operations of each other. They're effectively the same thing. And as was already stated, they move left to right. You've got to read these things left to right like you would read an English sentence. In the order that they appear, so that sometimes multiplication may appear before division. And then addition and subtraction, it's the same thing. Addition and subtraction are also inverse operations, but ped-masa, it doesn't roll off the tongue the same way. So we always write it as ending in as because it just sounds better as an English sort of word. But A and S, addition and subtraction, you're allowed to swap those for the same reason you're allowed to swap addition or division and multiplication, because they are also inverse operations of each other, and you read them left to right. They may appear in order or you write them in the order they appear. Subtraction may also appear before addition, which I'm hoping this isn't necessarily news to anybody, but this is the reason why. Cool? Okay, so I'm hoping BEDMAS is good. We like BEDMAS. So this first one here, what do I do first? Example 1. I do the 5 times 4 first. There are no brackets, there's no exponents, so I'm going to go straight to the division multiplication. I'm going to multiply these together. 5 times 4 is? So I'm going to get 3 plus 20 equals. And now we're done. Cool. Number 2, what happens here first? It's really tiny. Let's blow that up. Yes. Harwin. Sorry, number 2. We can go over here. Let's do it. The negative 4 plus 13. Why are you doing that first? Because there's brackets, and so we're going to do whatever math is inside the brackets first. Negative 4 plus 13 is? It's 9, and I'm going to rewrite this. 9 plus 18 divided by negative 2 times negative 3. Okay, how do we do this? Okay. I have seen this. Okay, so here we go. I've heard both now. Someone said I divide the 18 by the negative 2, and someone else said no, I do the 2 times the negative 2 times the negative 3. Which of those is correct? Because they're going to give me different answers. Okay, so let's settle an argument here. The brackets are screwing some of you up. Is there any math going on inside the brackets? No. So we can ignore that they exist. Okay? The only thing that these brackets are doing is they're containing these minus signs, so we don't think we're accidentally subtracting here. They're holding those negatives there, pairing them to the number, so that we can see that we have negative 2 and negative 3. We're not subtracting by 2 or 3. Okay? That's what those brackets are there for. There's no exponents, but there is division and there's multiplication. Those can be done in any order, but we have to do them left to right. So what happens first in left to right? The 18 divided by negative 2. So we've got to do it like this. It's going to give us 9 plus 18 divided by negative 2. And then we're going to multiply that afterwards by negative 3. If we do that, I'm going to get 9 plus negative 9 times negative 3. Oops, sorry. What happens next? Negative 9 times negative 3, which is positive 27. So I'm going to get 9 plus 27, which is going to give me what? 36. Okay? This addition of some of you have not seen this left to right piece here before. Left, it must be done left to right, otherwise it's going to give us a different value. The incorrect value it would have given us would have been, that would have been plus 3, so it would have been 9. Yeah, it would have been 12 instead of 36. Okay, number 2, what happens first? Why 10 plus 2? Who said that? Harlan, was that you? Why 10 plus 2? You're right. You are right. The 10 plus 2 has to happen first. There's no brackets there, though. There's nothing. So, but brackets happen first. There's none. Exponents happen next. There's none. But then division. Oh, well, there's obviously division. So what's the problem here? Actually, you can. You're going to see that in a couple months here. But there is an understanding here. Yes, Danny. Before I say what I'm going to say, you say you're going to say.
You read left to right, but you read up to down, and so it could be kind of like it's this. Like we read it 10 plus 2 divided by 8 minus 6. Like that's how we read it. We don't go 8 minus 6 divided by 10. Plus 2. But you just automatically read the top first and then the bottom.
Sweet. So there is an implicit set of brackets here that we don't necessarily C, but we need to understand that they're there. And I say this now like it's that I'm making a big deal, and you're sitting there like, obviously this is true, but I guarantee you're going to start getting sloppy in the future when you're like, I know how to do this, and then and then it's going to go badly for you. So there is an implicit set of brackets around what's in the numerator and what's in the denominator. You need to deal with those separately first. So the 10 plus 2 is going to give me, the 8 minus 6 is going to give me, so then I could have just written it like this. Well, 10 plus 2 is 12, and then that's there, and 8 minus 6 is 2, and now that's just going to give me 6. I could have just used a fraction. I don't have to convert it into this statement, but it is important that you understand that that's how we read it. Sorry? Which fraction? That's what I did. See, and that's the other piece to it. Fractions are just division. So when we say reduce the fraction or simplify the fraction, all I'm saying is do as much division as you can. That's all that's happening here. So to simplify or reduce this fraction, well, I'm just doing the division. That's 6. Cool? Last one is this. What happens here? What do I do with number 4? Five minus 1 happens first. Cool. So I'm going to have 2 minus 4 times. The 5 minus 1 happens first because it's embedded in the brackets. 5 minus 1 is 4 over 5 plus 2. Okay, what happens next? The negative 4 times 4. So you negative 16, so this will become 2 minus 16 divided by 5 plus 2. What's going to happen next? Two minus 16, or 2 take away 16 is? Divided by what's 5? We can do it one step. What's 5 plus 2? Negative 14 over 7 is? Negative 2. Okay, cool. Comments, questions, concerns? Okay. Then I am going, you guys know how to divide integers already. I am going to give you some time to work on some stuff here. We'll see how it goes. The last thing I want to do is, I don't have a space for it in the notes. I want you to flip to this page here. It says reviewing integer operations / bed maths. I want you to go down to the bottom here. I didn't have a place in the notes to actually review this, so I want to make sure that we review this thing properly now. Here's a number. 876,567.9801. I want to round that thing to a bunch of different places. How do I round? No. How do I round? What are the rules for rounding? Is that a hand? Yeah, Rebecca?
If you're trying to round it to the nearest hundred, you go to the tens power.
Okay, so hold on. So look at the place to the right of what you're rounding, or of where you want to round. Rebecca, keep going.
If the number is 5 or higher, you would round up 1.
So if it's 5, if it's greater than or equal to 5, round up. So if it's less than, no, I did this backwards. If it's greater than or equal to 5, you round up. If it's less than or equal to 4, you round down. Okay. And then what happens after that?
You change all of the other numbers to 0.
Excellent. Everything after becomes 0. And you're all probably sitting there thinking like, yes, this is obvious. It's not obvious. The number of grade 11s I have in my physics class who can't do this tells me it's not obvious. Okay, so I want to take this number and I'll round it to the nearest 100. So where do I look? So where is the hundreds place here? I'll zoom this in. This 5 right here is the hundreds. So where am I going to look? At the 6. Is that 6 bigger than 5? Yes. So that means the 5 is going to become, and everything after it's going to become 0. So the first numbers stay the same. The 8, 7, 6 stays the same. The 5 is going to become a 6. And then I'm going to get 0, 0. And I can drop off the decimal place. Okay, if I want to round this to the nearest 10, what do I do? Or what's the answer going to be now? Someone just tell me what the answer is. Okay, Harwan, is that you? You sure? 870. That correct. Okay, what's the nearest 10th? Where is my 10th spot? It's the first one behind the decimal. Love it. So if I want to round it to the nearest 10th, what do I do? Look at the hundredths, which is one to the right of that. So if this is an 8, that's bigger than 5, so what's that going to do to this 9? It's going to make the 9 what? A 10, which is going to make this place a 0, and it's going to make this place do what? Go up 1. So this is going to become 876,568. But the question says I want this rounded to the nearest 10th. Do I have a 10th spot here? No. So I have to include it. 0.0. The 9 became a 10, which made the 7 an 8, and I have to have that 0 in that spot. Because if I want it rounded to the nearest 10th, I need to have a 10th spot. Cool. I want to round this thing to the nearest 100th. What do I do? Sorry? I look at the 8. That's in the hundredths. So I'm at the 8, and I look to the right, which is the thousandth spot. That's a 0. 0 is less than 5, so what happens? Stays the same. And I drop everything else off. So if I'm rounding this to the 100th, this is going to become 876,567.98. And then what's going to happen here if I round this thing to the nearest thousandth? So tell me what my answer is going to be. Yes, it's going to end in 0.980. So it's going to be 876,567.980. And that 0 has to be there because that's my thousandth spot. And if I'm rounding to my thousandth spot, there sure as heck better be something in that spot. Okay? Comments, questions, concerns? Then I'm going to give you some time now. I want you to start, if I flip back, I want you to start here with the dividing integers. And I want you to go all the way. And I want you to finish all the way to here. The bottom of page 1 to the end of page 2. 3 and 4 are the same style of questions, it's just extra practice. Starting at the bottom of page 1, all the way down to the bottom of page 2. All of this. Stop at the star. I'm hoping this is relatively simple for you. If it's not, let me know. I'm happy to assist. Otherwise, may the force be with y'all. It's a race. Okay, so we are going to jump back into this. So if you haven't already, are we confused about the package situation back there? There are whole packages. Like, don't just take the top page. Each package, like, I put them crossways on each other, make sure you have the whole package. If you haven't yet, go grab the package. It'll start with adding or subtracting fractions. I was wrong before. I didn't screw up with the photocopier. I didn't screw up with the photocopier. I just had them upside down. So, we're going to start with adding or subtracting fractions. Oh, was there a mistake? Okay, so the packages alternate on top of each other. So you need to take a whole thing that's shaped, like that's facing the same, all the pages that are facing the same way. Take that whole stack. Oh no. Did it get messed up again? Okay, if you took from here, make sure that oh no. Okay, ladies who were here before Danny. Mangled things. Okay, ladies who were here before, make sure you have all of the pages. I had them organized nicely so that you just came and grabbed the whole stack. So it was a group of 4 pages that were together. You want to make sure you have all 4 pages. You start with adding and subtracting fractions. And then the next page is operations with fractions. And then converting. And then it says review, fractions, decimals, percent. So someone doesn't have the back page. Who does not have the back page? Good. Don't worry, when the photocopier works again, it won't be an issue. Someone is missing the back page. Okay. 4 pages. Okay, here we go. Before class ends, we're going to review adding and subtracting fractions in the 5 minutes we have left. So, here we go. Tomorrow the first thing we'll do is we'll go over all the answers to the homework I assigned. So if you don't have them, don't worry about that. We will go over that tomorrow. So, adding and subtracting fractions. When adding or subtracting fractions, what do you have to have? You must have a? Yes, instead of the word same, we use something else starts with a C. A common denominator. In other words, the bottoms must be the same. How do we do that? Yes, we have to find a lowest common multiple. So what we want to find is the smallest number. Well, it doesn't have to be the smallest, but we want a small number that both of the denominators go into. So I got 2 and 3. What is the lowest common multiple of 2 and 3? 6. Doesn't have to be. We could have used a larger multiple, but the smaller the better. Means we reduce less later. So if the common denominator is going to be 6, what do I have to do to this fraction to give it a denominator of 6? Times what by 3? If I times the 2 by 3, then I have to multiply the what by 3? Numerator. So I'm going to multiply the numerator and the denominator by 3. Times by 3, times by 3. And that's going to give me 3 over 6 plus Now, what do I do to this guy here? I want to multiply the top and bottom by 2 times 2 times 2. So this is going to give me 3 over 6 plus 4 over 6. And now what do I do? Now I add across the top. And what do I do to the denominators? It stays the same. Cool. Comments, questions, concerns? Is this ringing bells vaguely? Okay, cool. So what do I do with this guy? So this, the lowest common multiple of 9 and 3 is 3. So I don't have to do anything to the first fraction, but I multiply by 3, I multiply by 3. So that's going to give me 7 over 9 minus 3 over 9, which is going to give me, sorry, 4 over 9. Because I was subtracting. Make sure you read the questions. It didn't come up with either of these questions, but when we're dealing with fractions, what must we have? We must write the fraction in what state? The fraction in, yes, in lowest terms. Which hasn't come up yet, but it might at some point in the future. What if we're dealing with a negative fraction here? I've got negative 2/5 minus 1/4, and that negative is just written out front. What do I do with this to make our lives easier? Oh, you know what? We'll find out tomorrow. You have nothing beyond what I assigned earlier. Get that done for homework. I will see you tomorrow. This, the first thing I assigned. This to the end. That's all you've got. We'll see you tomorrow, guys. It is, well, yeah. Head to your third period class. If it's on the first floor, you got lunch. Yeah, it's just the first thing I assigned, yeah.